Question number 63. A uniform rigid prismatic bar of total mass m is suspended from a ceiling by two identical springs as shown in the figure. Let omega 1 and omega 2 be the natural frequency of mode 1 and mode 2 respectively, where omega 1 is less than omega 2. The value of omega 2 by omega 1 is. So this rigid bar is suspended from a ceiling with two identical spring of spring constant K, right? So there will be two modes of vibration. Let's see those modes. So this is first mode, in which it will vibrate like this, and this is second mode, in which it will vibrate in this manner. Correct? Now let's write the equation of motion for these two modes. Then we will find out frequency of vibration for these two modes, right? So first of all, for mode 1, m k k. So let's write the equation of motion. M x double dot is equal to minus 2k x. So mx double dot plus 2k x is equal to 0. So we can write x double dot plus 2k by m into x is equal to 0. So if we compare this equation with basic equation of vibration, then frequency of vibration, let's say omega 1 is equal to under root of this thing, correct? So under root of 2k by m, right? Now let's find out for second mode. Let's say this is theta, this is L by 2. So extension of spring will be L by 2 into theta for smaller angle approximation, correct? Here compression of spring will be L by 2 into theta, correct? So let's write the equation of motion. I theta double dot is equal to minus spring force will be K into this much distance. And what about torque about this point? This force into distance, that is L by 2, this distance, correct? So we can write force, that is K into L by 2 into theta. This will be force, but this is torque equation. So force into L by 2 will be the restoring torque for this spring, correct? But there are two springs, so this will also give the restoring torque like this. So we'll directly multiply with 2. So I theta double dot is equal to minus K L square by 2 into theta. I theta double dot plus K L square upon 2 theta is equal to 0. Theta double dot plus K L square upon 2I theta is equal to 0, right? Now those people who have attended the class at Aerospace Academy, they might ask that why we are writing independent equation that is uncoupled equation for mode 1 and mode 2. Why not coupled equation, right? So answer for that question is, see, coupling depends upon the coordinate system we choose, right? We can choose such coordinate system that will make our equation independent. Even if you write coupled equation, still you can use few relations to make that equation uncoupled, and then both equations will be independent of each other. Like here, this is completely independent of this, correct? This equation and this equation, we can solve this equation independently. So this is the answer to that question which you may ask. So let's find out omega 2. So if we compare this equation with fundamental equation, then natural frequency, let's say omega 2, will be under root of this thing, correct? Under root of k L square upon 2I. Now let's substitute the I value. Mass moment of inertia, we already know, that is ml square by 12, correct? So 2 into I is ml square by 12. This will get cancelled out. So omega 2 is equal to under root 6k by m. So let's find out the ratio. Omega 2 by omega 1 is equal to under root 6k by m upon under root 2k by m, right? This will get cancelled out, so it will be under root 3 1.73